Alright, I'm going to move on to the final example, but before I do, I wanted to go back here really quick and talk about substituting into the trig identities. For this one, it worked to use the standard Pythagorean identity, but, and this was number 10, but if we had started with, for example, a equation where this had a 2 in it instead, like sine of 2t, then you would want to look at your identities for what does sine of 2t equal. So you're not always going to use this one trig identity. Sometimes you're going to use different identities, so just be aware of that. You're going to pick the identity that will work with the trig equations you were given. Okay, so the last example for this section is finding a parametric set of equations for a line segment with endpoints -1, 3, and 3, -2. Now you'll see in the instructions it says find A. That indicates, that word right there is key, because that indicates that there's actually multiple answers. So usually the easiest thing to do is to think about these starting at t equals 0 and moving into the positive direction. But technically, you could use t between any values of t that you wanted to. It's just, it's easier to start with 0, of course, because 0 is always easier to work with. But there's multiple answers for this. But we're going to first, what I'm going to do is consider the endpoint -1, 3. And I'm going to let x equal -1 plus at and y equal 3 plus bt. I'm doing that because I know that this is a line segment, so my parametric equations are going to have to be in the form of lines. So now if I do that, I have set up a set of parametric equations here that's going to represent a line going through the point that I want if t is 0. So in other words, if I plug in 0 for those t's, I'm going to get x equals -1 and y equals 3. So it goes through my endpoint. So that gives me my first set. Now, what you want to do is you want to look at the other endpoint. So the other endpoint is 3, -2. So let's assume that the parametric equation is going to work so that it goes through this point if t is 1. So at t equals 1, we're going to go through that point. I use the same equations that I had above, these two, and I plug in x is 3 because that's where I'm at now, so x is 3 and t is 1. That lets me solve for a, and then do the same thing. If y is -2 and t is 1, I can solve for b. So b is -5. That gives me my set of parametric equations. So the one possible solution would be, once you find your a and your b, go back and plug them into these original ones, and you get x equals -1 plus 4t, and y equals 3 minus 5t, and that is for t between 0 and 1. But like I said, you can absolutely positively pick any t values that you want. You could set this up for all t greater than or equal to 0. It just depends on what you want. Now, this one is a line segment, and it has definite endpoints, so I probably didn't give a very good example for t greater than or equal to 0, because t greater than or equal to 0 would not have an end. It would keep on going in some direction. It would have a continuous path forever. And this obviously does not. So, for example, if you go back to, I think number 2 was the first one I did, we had t greater than or equal to 0 on that one. That graph goes on and on forever. On number 10, we were between 0 and pi. It had definite endpoints, so it started somewhere and it stopped somewhere. So when you want a line segment, you're going to want to make sure that you have your t set up so it starts somewhere and ends somewhere.